Alright guys, time to sort it out. Here we have Newton's law system, no friction. So we have a two-block system over a pulley, and our goal is to find the acceleration and then the force of tension in the string. So when we're working with system, let's start with this. The acceleration of the system is going to be the net external force on the system divided by the mass of the system. So let's call this M1, let's call this M2, and for this problem, let's do down is positive. So let's think about all the forces on the system. For the block on the table, you have force of gravity down, and you have force of normal up, but neither of those is going to create a net external force on the system. For the hanging mass, you have tension up, and you have gravity down. Now tension is internal to the system, and the force of gravity from block 2 can create a net external force. So here's our expression for the acceleration of the system. It's going to be the weight of block 2 divided by the total mass of the system, where we'll sum the two blocks together. So go ahead and calculate that. See if you can find the acceleration of your particular problem that you have. So that will give our acceleration, and this is a system, so all parts are going to accelerate at the same rate. So then the next part is that we need to find the force of tension. This can be a little bit more challenging, so let's do a free body diagram for this. So for the hanging mass, we have tension up and we have gravity down. These should be straight up and straight down, but we know that the system is going to accelerate this way, so gravity has to be greater than tension. We drew that in our diagram here. Then we write a sum of forces expression. So let's focus just on block 2. So there, the net force on block 2 is going to be equal to the mass of block 2 times its acceleration, and that's what we found in the first part. So the net force is going to be, remember we said down is positive, so force of gravity minus force of tension, because up is negative in the way that we chose our reference frame. So gravity minus tension, let's rearrange this now. Move gravity over to the right hand side, then distribute the negative, then plug in force of gravity on block 2 is the mass of block 2 times little g. Now we can factor out M2, and we're left with this. So the force of tension that you're looking for, it should be given by this formula, using the acceleration that you found in part 1. Okay, try it out. Alright guys, back. Going to show you another approach to this problem. And we use the hanging mass to find the tension previously. There is a simpler approach. You may have thought of it. The net force on block 1. Now, there's no friction on the table, so the only force is the tension and the string on block 1 directly. So besides normal and gravity, so that would cause the acceleration to the right. So if we just focus on the mass on the table, we can do this the same way. We'll find the tension. It's simply the mass of block 1 times the acceleration of the system. Try that. Maybe a little simpler, a little bit quicker for you.